Hi all, welcome to the second session of the fourth series of free training. We are happy to share with you that we are awarded and recognized by Gartner Magic Quadrant 2023 and Peer Insights Customers Choice 2022 and Enterprise World CIO Select Award. The agenda for today's session is to understand application performance with Apdex course, monitor code flows across applications via distributed tracing, pinpoint to the problematic elements in your application code, visualize dependencies in your application architecture with automated service maps. Before discussing the topics in the agenda, let us start off with why an application performance monitoring is needed. For that, let us uh, see a short story optimizing the e-commerce website experience with APM Insight. So there was an ambitious e-commerce website which aimed at revolutioning the online shopping. However, they had some difficulty in capturing the real-time information, some complex set of codes with varied use cases. So in this case, imagine a user is accessing an e-commerce website and purchasing the things from the online store. On completion of the selection of items, they are attempting to place the order. At that time, in the payment portal page, they encounter issues like the portal taking a long time to load or getting redirected to a different page or showing some error codes. So this could lead to losing of potential customers from accessing the application and which will lead to loss of business for the developers who are working in this web application who are unsure of the root cause of the issue. So in this scenario, the demand for using an application has increased, which has also led to the complexity in its development. Hence, it is necessary for the developers who are working in the application to make sure that the website is bug-free and handles the load in the application's database to ensure providing a better service to their users. Let us see some of the recent facts that are gathered by our ManageEngine team. The first fact shows that customer experience being a top priority for 71% of large enterprises. Using the Apdex code, we can gauge the customer experience and utilize the traces capabilities proactively identify issues even before they are reported by the customers. The second fact highlights the common challenge faced by many business in understanding the complex relationship between different components within their application. The service map in the APM Insight tool automatically will map the relationship between various components such as the servers, databases, and third-party services in complex application architecture, and will also provide insights into how the different elements will interact and impact the overall performance. So these are some of the latest trends in the application performance monitoring. The first one is cloud native APM. So as we know, recently more applications are moving to the cloud. Application performance monitoring solutions are adapting to monitor cloud native architecture and microservices and containers for scalability and also for flexibility. The second one is artificial intelligence for IT operation capabilities. So by including artificial intelligence for IT operation capabilities, which will enable anomaly detection and predictive insights, and also will automate, which will help in enhancing the problem resolution. The third one is user-centric monitoring. With a growing focus on monitoring user-centric metrics such as the load times, the interactions, and satisfaction, which will help the business prioritize improvements and also will ensure to improve the customer satisfaction. The fourth one is application observability. The traditional APM is gaining insights into application behavior using metrics, offering deeper insights into distributed traces and logs for better troubleshooting and root cause analysis. And the last one is full stack performance monitoring. Beyond the traditional performance monitoring, the application manager solutions now includes the full stack observability like monitoring infrastructure, databases, and application code to gain a holistic view of the entire system's performance. So these are some of the benefits of modern versus the traditional approach in building an application. The first one is the application availability. We are aware that there is a dependency on application in our day-to-day life. So with the increasing dependency on application and wide usage of it has made the application to be always available for the users. So a group of microservices are built instead of a large monolithic application. The development of technologies like containerization and load balancing has helped the organization to achieve this high availability. The second one is cost reduction. With the advent of the cloud computing capabilities, the organizations no longer need to spend more money to build large infrastructures and thereby their capital expenditure. The third one is compliance tracking. We know that every applications are developed based on a particular standards. So depending on the industrial standard like HIPAA for healthcare, FIPS for USA government, we can easily track if an application follows those standards. And the last one is operational efficiency. So as we have already discussed in our last session, using the dependency mapping, you can easily identify the faulty component of the application quickly in a single click and also identify the down application more faster for instant diagnosis of the problem. So far we have discussed why an application performance monitoring is necessary. In Applications Manager, the performance monitoring tool is called APM Insight. The APM Insight will give you an understanding on the way your application is behaving for the end users who are accessing it. By a complete end-to-end transaction, monitoring across your entire web application will help you to avoid any performance issues. Also, you can analyze the root causes of the problems much faster by performing the first level troubleshooting. The supported technologies in the APM Insight are Java, Node.js, .NET Core, Microsoft.NET, PHP, Ruby Rails, and also from the latest Applications Manager build 16650, we have started to support Python technology as well. So for some of you who have been already using the Applications Manager and the APM Insight, you can find the difference between the old and the new GUI. So in the new GUI, we have revamped the APM Insight monitor. As you can see in the new Home tab, the list of applications that are monitored will be available, which will have the availability filter. The agent type icon will also be available for it. And you will have the custom attribute filter, inline filters, trend graphs are available in the latest builds. Under the Overview tab, we can see the overhauled application data GUI with the availability and health, the agent type icons being added, and the monitor actions are also present. Duration select, which will help you to select the time period when for which duration you want to see the data. The agent last communicated time widgets are added. Under the transaction tab, we can find the key transaction intimation. In the traces, we have overhauled the traces details GUI with tree view with progress indicator pop-up floater and a SQL and also the exception traces. So we will all see this new GUI one in the later part of the session. So these are some of the factors that are affecting the application performance. The first one is response time. When a transaction is made by an user in the web application, the request is sent from the application layer, which will travel through the transaction and the network layers and will hit the application server. And this request will be served back to the end user. In case of slow connection to the web application, which can lead to network traffic, and the transaction consumes a longer time, which can lead to a poor response time. The second one is application code. An application is developed using certain technology, which will have a large number of bugs that are affecting the functions and the overall performance of the application. The bugs in the code can cause exceptions that might result in the transaction execution failures. Stack trace can be used to identify these codes issues and also to improve and fix the application code. The third one is memory. High usage of the web applications and not optimized application at the code level may cause some high consumption of the memory from its allocated space in the machine, which will lead to memory leaks and also out of memory. The last factor is database. For instance, the database calls and the queries pertaining to a specific transaction could become highly loaded, affecting the performance of the application. Hence, for the developers who are working in the application can be dependent on this APM Insight monitoring tool to keep an eye on the factors that are affecting the performance. This is the functioning of APM Insight. The APM Insight is an agent-based monitoring tool. The first step involves deploying the agent on the application server where the application are running. These agents are responsible for collecting the performance data and sending it to the applications manager for analysis. The agent, which is residing in the application server, uses bytecode instrumentation method, and it will start tracking the individual user transactions as they flow through the application and sends it to the applications manager at a fixed time interval. This allows for a detailed monitoring of the transaction performance and will help us to identify any bottlenecks or performance issues. So this tool provides a code level visibility to monitor slow database queries and their performance by capturing the real-time user interactions with the application. And also you can configure alerts and notification based on the predefined thresholds for the metrics that impacts the performance of the application. When the application performance exceeds these thresholds, the tool will send an alert to the IT team, which helps the developers and also the IT team to identify the areas that needs a more improvement in the performance, like the application code, database related issues, and page load times, which will help in enabling them to proactively address and issues and minimize the downtime. These are some of the key performance indicators of the application performance monitoring. The first one is Apdex score. The Apdex score, it is a numerical measure of user satisfaction with the performance of application's response time. The second one is response time. The measure of the average time it takes for the application to respond to a user's request for the transaction across the application. Lower the response time are generally more desirable. The third one is request. The request counts the total number of requests made to the application within a specific time frame and helps decide the overall workload and usage of the application. The fourth one is data throughput. It indicates the amount of data in bytes which are being transferred or processed in and out in the network request by the application during monitoring period. It also helps in understanding the application's data handling capabilities. And the last performance indicator is exception, which will track the number of exception errors or failures that has occurred during the cycle of transaction in a selected time period processing of request. These exceptions could be of various types of errors such as server errors, timeouts, or other issues that affect the application's normal operation. In our first topic, understand application performance with Apdex scores. There are three categories of the application responsiveness. One is satisfied, tolerating, and frustrated. The satisfaction category represents the highest level of user experience, where the application's response time is between the satisfied threshold and the excellent threshold. Users in this category are generally satisfied and happy with the application's performance. The second one is tolerance. The tolerance category indicates that the application's response time is in between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance, but may not be entirely satisfied as user uh, under the satisfied category. And the last one is frustration. So this category represents the lowest level of user experience where the application's response time is below the tolerating threshold. So users in this category are likely to be more frustrated and sad with using the application's performance, and it does not meet their expectations. Tracking the application performance with Apdex score. So let us see the definition of this Apdex. So the application performance index or Apdex score, it is a standard metric which is used to measure the satisfaction with the application response time. So the Apdex scale, it ranges from 0 to 1, with 1 being the best score representing excellent user satisfaction. So the Apdex score is calculated as the sum of satisfied count added to the half of tolerating count over the total samples collected on the user transaction in the application. These are some of the advantages of monitoring application performance with Apdex score. So first one is user-centric performance measurement. So this will help you to understand how application performance directly impacts the user experience and enables you to prioritize the improvements. The second one is easy interpretation of complex performance data with a common performance metric, which simplifies the complexity of the data into a single and easily understandable metric by providing a clear and standardized way to assess the application performance. The third one is benchmark and compare the performance level of your different applications. You can benchmark and also compare the performance levels of different applications. This will allow you to identify the high performing application, leading to consistent improvement across your IT environment. The fourth one is proactive issue identification and prioritization of code optimization. So when the performance falls below the acceptable levels, the Apdex score will help you to identify critical transactions with low scores. This will help you in highlighting the areas for the code optimization. Alerts can also be triggered, enabling you to quickly identify the issue and improve the key transaction that impact the user satisfaction. The last one is historical trend analysis to improve your user experience. The historical Apdex score trend data will allow you to analyze the performance pattern over time in helping and understanding the performance trends, which will help you to identify the issue and improve the user experience and also ensures a consistent positive user experience. So by now, you would be interested in configuring the key business transaction to monitor the entire performance of the application effectively. So in this slide, we shall see on configuring the key transactions of your business operation. There could be a high volume of activities made in the application. So all the transactions would be captured, among which you can select the key transactions that you want to monitor in it and set the threshold based on the response time of the transaction. Second topic in our today's session is monitor code flows across applications via distributed tracing. In a microservice architecture, it is necessary to monitor the transaction made between two or more applications or services. With the help of distributed tracing feature, you can track the transactions made between two or more applications. So let us understand how the tracking can be done in distributed tracing. When an API request is made by an application to another application, the APM Insight will add an HTTP header which contains the metadata required to track the request. If APM Insight is enabled in the other application, it will process the HTTP header and return the tracking information to its caller via response headers. If the other application in turn calls another service, the header propagation would continue and traces all the paths taken by the original application across the distributed setup. So using this data, we can monitor the start time, that is when the transaction was initiated, the response time taken for the transaction to respond within the application, and also the name of the transactions and the applications. By clicking the expand tree view of the application name, you can view the method calls and the code blocks that has taken a significant amount of time to complete the request, and this will help you to monitor the calls made between two applications and narrow down the problem. The next topic is auto scaling. This is an automated way of managing the resources of your application. Imagine you have a website or an application running on the cloud environment. Whenever the application automatically scales up due to high user interaction in the site, and to handle this extra traffic, a new instance will get added. However, when these applications are scaled down due to lesser user transactions, the newly added instances become unused and are still retained. This can lead to the license being consumed by the unused instances, resulting to the new instance not being added for monitoring. Hence, with the help of the auto scaling mode in the APM Insight, you can overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. The third topic in our today's session is pinpoint to the problematic elements in your application code. Here, let us see the need for eliminating the issues in the problematic code. As you are aware, the stack trace represents the movement of an application during the execution of a program. When the Java application throws an exception, stack trace gets logged with it. By analyzing the stack trace provided by the APM Insight, developers can pinpoint the exact line of the code and the sequence of function calls leading to the issue. This information helps them to understand the root cause of the problem and can make the code optimization or the bug fixes to eliminate the issue and improve the application performance. With the stack trace, developers can effectively troubleshoot and resolve the problems within the application's code and ensure a smoother and more reliable user experience. Gaining deeper visibility into Java-based application performance using context-based monitoring. You can enable context-based monitoring for your Java application specifically. So this will allow the tool to track and trace individual user transactions, capturing the data on how each registration transaction flows through your application server. Let us say your application server has 3 Java applications running on it. By default, the transactions of all application coming from the same application server are shown collectively under the Web Transaction tab in the APM Insight. In the image, as you can see, the Tomcat application is the application monitor name, and JPEG store sample and sample web app are 3 contexts running on the same application server. The transaction of these 3 Java applications are listed out in the Web Transaction tab. Now, with the context-based monitoring, you can monitor the performance of all the individual application running in the same application server separately, which will help you to analyze your application performance. So this means that by enabling the context-based monitoring, transactions of the JPEG store, the sample web app, and the sample can be viewed separately as well. So moving to the last topic of our today's agenda, visualize dependencies in your application architecture with automated service map. So what is a service map? It is a complete overview of the application infrastructure with the connection to the other dependent resources. So the use of the service map is to easily identify the status of the application and the instances, monitor the key metrics like the response time, throughput, and status of connection, detect and troubleshoot the application problem before the end users are getting impacted, and also to identify the number of failed request counts. There are three types of service map. One is the map view, the second one is the table view, and the third one is the graph view. So this is an image of how the map view will be. So here in the map view, it will provide the way of analyzing the topological view of the application, and along with its instances are represented in the central node. So now let us look on how all these can be achieved in the APM Insight monitor. So this is the overview of an APM Insight monitor. As we can see here, these are the key performance indicators like the Apdex score, the response time, the request. So the overall transactions that are made in the application, depending on which the key metrics will be monitored here. So you can see the response time broken by its component like the application code, the database calls, and the overall response time, the transaction list, the exception count, which will show us the fatal and the warning metrics along with its 95th percentile, the exception split ups, and the data throughput. So here we can also find out overall the top 5 transaction by the response time and top 5 slow traces for the each and every transaction that are made in the application. We can also see the recent 5 exception traces and the recent 5 error transactions. So here in the transaction tab, we will be able to monitor the transactions that are made. These are individual transactions that were made in the application. So this will display the transaction details that are pertaining to the action, which consumes a longer time, the frequently accessed actions, and it will provide a tier-wise breakdown of the transaction response time. For example, you will be able to see the JVM, the database, and much more information from it. So this will provide the information from the application level to the individual transaction level. You can also view the various transactions that are running as web transaction, the background transaction, or the errors. So this is one of the view of the transactions. So here you can go to the table view, and which will show the information in a table format. We have an option of marking the key transactions. So once the key transactions are marked, all those data can be viewed under the key transactions tab. The next one is the database tabs. Here under the database tab, you will be able to identify the individual database call made for each and every transaction that were made in the application. So under this tab, you will get the details of the performance metric to identify the slow database calls, the database usage, and the overall performance of the database, which furnishes the detailed graphical and also the through the tabular representation. By clicking on the individual database operation, you will be able to view a list of web transactions that were performed by that particular operation. So this will allow you to narrow down and also to isolate the root cause of the performance slowdown. So which will here in this page, as you can see, you will be able to find the response time taken for that particular database call, the number of requests made, the recent traces will be available, and also the response time taken by the database operation, the throughput of it. Also, here we could see all the database calls made. But if you would like to know individually, like the select database calls or the update database calls, we have segregated this in our latest builds. So this will help you to easily monitor the individual database calls depending on the type that you're looking for. Next is the traces tab. So here under the traces tab, for the individual transactions made, there will be a set of traces collected for the individual transactions. So these traces will help you to get the insights into how the individual transactions are running within the application. So all these traces are kind of snapshots of the transaction, which will help you to identify the performance bottleneck by drilling down to the transaction and also identify the trouble. So as you can see here, for this particular transaction that I have selected, this is the trace details. So the trace details will have the method calls used by the particular transaction along with the SQL statements involved in it. So you can try to identify which particular method call has consumed more time, and those can be used for the developers to easily handle in the product. Also, the SQL statements that are running for that one particular transaction can be identified. You can also monitor the remote external calls that are involved by that particular individual user transaction. The other traces of this particular transaction, like the response time and the throughput, the metric, the other traces of the transaction can also be found, which will help you to identify the slowest and also the most recent ones. And if you're looking for the JVM, that can also be found out for that particular trace. So here, moving on to the next tab, which is the JVM tab. So this JVM tab, it will be available only for the applications that uses the Java technology. So here in this tab, it will help you to monitor the Java application by monitoring the application code that is running on your JVM. So it helps you to monitor some of the crucial metrics of your Java application and will provide deep insight by visualizing the performance and also represent them in a tabular and also graphical representation, which will help you to gain much more visibility on how the resources are being used and are also impacting the Java application. As you are aware, these are some of the key performance metrics of the JVM, like the JVM CPU usage, the classes count, the heap memory and the non-heap memory, and runtime memory. So all these can be monitored under the JVM tab. So we will move on to the reports and see how the reports can be, how the data can be exported as a report. So here in the at a glance report, you will be able to identify the response time, the Apdex code, so which will provide you the overall metrics, overall performance metrics that are available. And when you click on the individual metric name, it will show you how the individual metrics data are behaving in the application, which will help you to identify the performance of the application and handle it in the. So we do have the option of configuring the alarm. So as you can see here, these are some of the key metrics for which you would be able to configure the alarm, like the Apdex score, the response time, the frustrated, satisfied, tolerating. So these are some of the key metrics for which the alarms can be configured. Okay. So this brings us to the end of the training session. So let us have a quick recap of what we have discussed. So till now we have discussed about tracking the application performance using the Apdex code, finding the problems in the application code, then tracking the transactions from one application to another, and also debugging their issues, identify the problems in the code stack and how the service map will make it easier to identify the problems, and configuring alarms and reports in the APM Insight. Thank you for showing your interest in attending the webinar.